If you're not part of the solution, you're part of the problem. So if you create a substandard building, you're creating a problem for yourself plus the future generations. If you provide a good building, you not only providing good building for yourself, but you contribute to the longevity and the future of next generations that's going to live and buy that house and live in it, in the future.
ProClimber inspires and educates people to create healthy, durable and energy-efficient buildings to live, learn, work and play in. Welcome to the ProClimber podcast. In today's episode, I speak with Freidrich Strey. In this episode, we hear about his life growing up with frugal parents in South Africa and learn how this helped mold his career as a sustainable architect. Good afternoon, Freidrich. How are you doing?
Good afternoon, Simon. Really good, thank you.
Just to kick off the discussion here today, Freidrich, can you give us a little bit of an idea when you were growing up in South Africa, what was it that inspired you to go into architecture?
That's a tough one because initially I think I just liked drawing and I ended up going to a technical school and there they had technical drafting as a subject that you had to take. I did really well at it and really enjoyed it. And then I thought, okay, I like design and I like the way buildings were put together. I helped my dad demolish buildings for motorways because he was a civil technician and on the sideline, he could make extra money doing this. So I saw how buildings were put together and he was very hands-on as well. So I worked with him, or I had to work with him for my pocket money, really growing up. And all of those things inspired me, I think, to start studying architecture, which was something totally different to what I actually expected to be, but in a good way as well, because it was so much more than what I thought it would be.
So we've talked a lot over the years about design, and I can sense that you're quite inspired by sustainability and building buildings that are able to heat and cool themselves through passive technologies and things like this. Can you give us a bit of an idea what excited you and what drew you towards that sort of side of building?
I think, again, it was growing up with the way my parents looked at everything and how we lived just naturally. Like, for instance, my dad had an earthworm farm because he liked freshwater fishing and he used that as bait. And obviously we had to feed the worms, so all the food scraps and so on went into the earthworm farm, and the tea from it was used in the vegetable garden, and we used the vegetables again in the house. And that was one thing. And then the other thing I can remember is that we always had a bucket with us, like an HDH. I don't know if you remember.
Yes, the pool
chemical bucket, like a 20 liter or so, with us in the shower. So any water that would miss you, basically, or comes off you, falls in the bucket, and then we'll use that water in the garden as well, instead of having that water just drain down the drain. So just principles like that, and then obviously switching off lights when you're not in the room, saving energy, not so much to save money, but I think just not to have anything go to waste. I think mostly also because my father and mother grew up during the Second World War and they didn't have a lot during those days and every little thing was valuable. So they kept on living like that and just transferred that way of living or lifestyle to us children and making us aware that we have limited sources or resources of energy and we should be frugal with it.
Now, over the years, you've designed, obviously, a number of projects and you've really taken a hands-on approach. You know, a lot of architects just do the design, but it sounds like you actually like getting your hands dirty. What got you interested in actually moving down the line of actually building as well as designing?
I think it's a combination of just circumstances as well. Growing up using my hands and making things, helped my dad build a full-scale doll's house that we could play in and so on as well. building little boats to float in the water channels after rainstorms, all those kind of things, making things with your hands. And then that ended up, I built a car after finishing school because it sounded like a good adventure and it was a cheap way to have a car. Learning things around it as well, like spray painting and so on. And then finishing uni, the interest rates were very high at 27%. Not a lot of people got any jobs really coming out of uni. So a friend of mine asked me to design a house for him in exchange for a ski holiday. Long story. But I ended up designing the house for him. And then the tenders came in high because it was a very difficult section, steep rock plate, basically 300 square meters with a double-story house perched on it and around a fig tree growing out of a crack in the rock that I didn't want to, take down. So I designed a house around and over it as well. So anyway, it came out that it would not be affordable. So foolishly, or maybe unfoolishly, I don't know, I agreed that I'll build it for him. Taking on a massive project as a young person, but I learned a hell of a lot from it as well. Not only about whether what I've designed, how executable it is or not, but also how it's put together and obviously managing teams, costings, managing time, people relations, all of those kind of things that you learn. And then I was recommended by a friend of mine who was going to leave his job as a replacement for him. So I went for an interview and got the job. And then I ended up, managing a team before work, lunchtime and after work, because I was lucky to be near the site. The office was near the site as well. So I finished off the house while working. And then from this house, I started getting other jobs, which the architect that I worked for graciously allowed me to do because it wasn't really in competition with his or the projects that we were working on. And I ended up working at night for myself and during the day for him. And then at some stage, he lost a major client and couldn't really afford me anymore. And I had more than enough work for myself. So I started my own practice straight out of that. And yeah, it worked out really well. But that's, I think, where it all started, working with my hands, building the first house, and then just loved it. I like variety as an architect as well, not doing the same thing every day. And could be so diverse. And the construction part of it makes sense as well because you have to be able to build what you design and you understand better what you're building if you can build it yourself as well. And also you can relate better to the contractors on site and the challenges that they face. And you can also show them that what you've designed is possible and executable. And I'm always open to new ideas. If they have a better idea of doing something, then I'm open to listening to that. But usually they understand that this alternative way that I'm proposing is not necessarily a bad thing. Alternative could be progress. It's if you don't change things as you go along positively, then you fall behind, you get stuck in the past. And if we didn't change things, we would still be staying in caves, basically. Although there won't be enough caves for all of us. So, we would have been forced to find alternative ways of accommodation.
So just going back a step on something you said earlier, you built your own car. Tell me about that.
I wanted a motorcycle when I was about 15, where you could get a license for a 50cc in those days when you're 16. And my dad didn't like the idea at all, but my mom luckily convinced him that if I would buy my own motorcycle, then he'll allow me. So he thought that I'll save money like from 16 to 18 and then not want a motorcycle anymore and use the money to buy a car rather. So he thought, that would be fine with him. But then I took on 2 jobs and saved enough money for a second-hand motorcycle and bought this motorcycle. So by the time I was 18, I did want a car, but I used the money for the motorcycle and running the motorcycle, petrol and maintenance and all of those things. So I thought, okay, a way to have a car was to buy a wreck, like a scrapyard. So I bought a written off Beetle that didn't have the mud guards and stuff anymore. And I bought a rusted engine for, I think $3 in those days. But there was a company that had a deal that you could bring any engine, and if you pay, I think it was like $100, you get a reconditioned Beetle engine, basically. So I brought them this Rust Bucket $3 engine, and they had to obviously do what they promised. It was, even in those days, difficult to find new mudguards or alternative mudguards and everything. But you could buy a kit, like a beach buggy kit called the Baja kit, or Baja, where it comes from in Mexico. So I bought this kit, and then I had to obviously sand and spray paint this entire thing to look new. The floor pan was a little bit rusted, but my dad picked up a massive stainless steel tank next to the road somewhere. So we cut this open and riveted this to the entire underside. So it had basically a thick stainless steel skid plate, indestructible. And then for my birthday, I got Yokohama tires and Smith wheels. So basically I created a kind of a beach buggy, a Baja bug, and I drove that for about 5 years, and it was really indestructible. I could drive up pavements, and perfect student car, I would say. Wow. And that's how I ended up building a Baja. And then I sold it for more than I paid for it, basically, afterwards.
That's pretty good, eh? Now, Freidrich, over the years, you've obviously won quite a number of architecture awards. Tell us a bit about that.
Well, I know the first award that we got was for a house called the Loft House. The reason we called it the Loft House is it was a narrow, long section down a hill facing south. In the southern hemisphere, you want, obviously, northern sun. So it was facing the wrong way, with the original house on the northern side of it, or to the northern side of it. So it was not entirely blocking the sun, but at least it took away privacy and views towards the north of the section. And then the section had beautiful grown trees, which me and the clients wanted to retain as much as possible. And then it was obviously more costly to build on a steep side. And the way it's normally done is either on piles or on strip foundations that need to step down the hill. And it's difficult to work on a steep hill as well. So what I did in the end is I designed a house that had an anchor wall running east to west following a contour. So it's easier to do one line of strip foundation along this contour, and then hang a steel structure off it towards the south with a few footings or pads. And so you had limited places where it touches the ground, and therefore it's easier to provide or to construct those foundations. And then put a floating, in inverted commas, skillion roof on top of that steel structure, with the high side facing north, so that you catch the low northern sun in the winter time and get light and sun deep into the building in the winter. But with the high sun, or the high angle of the sun in summer, the roof with its overhangs blocks the sun off anything else. So this wall had to become a thick wall as well to act as an anchor for the steel structure without having the steel in it as well. And I made it even thicker than it needed to be because of the thermal flywheel effect qualities that it would have. So basically the idea is that with a low sun and deciduous trees, so the trees drop their leaves in winter, so they do not obstruct the sun in the wintertime or during the wintertime, and the sun shines on this thick wall, and then it starts heating the wall, and then the heat transfers through the wall slowly, and a few hours later it starts emitting the heat on the inside. And also because it has concrete slabs tied, like sitting on the steel frame but tied into the wall, the heat is also emitted into the concrete slab, which is more mass. And then beginning of the winter time, or as soon as the sun starts shining on the wall, more on the wall, it starts charging the house essentially. And then During the night, obviously, you don't have that solar gain anymore. So you have the thickness of the wall of the heat to still move through the wall and the slabs to emit the heat. And then during the day, it charges again. The opposite happens in summer. We have the high sun, the trees with leaves shading the wall. So then it acts like a cave or a very thick farm-style kind of desert house where you have thick walls and it's nice and cool and a constant temperature inside. But not entirely, because the entire south facade was glass or is glass, and for the beautiful views towards the south. So you've got good southern light, beautiful views, and double glazing as a thermal element, but obviously it's not as good as nearly anything else because windows are basically a hole in a thermal envelope. And we have small apertures in the northern wall and a single deep space so that you can open the windows on both sides and then you get good cross ventilation through the single deep space. It's nice and cool again in summer. Plus we had a lap pool or a long water body along the entire length of the house, or nearly. And that, with the wind coming from the northern side in that area and the evaporation of the water, it would cool the air, and the wind or the breeze would blow the cooled air through the house, through those apertures, cooling down the house. So passively, it was heated in summer without paying anything for it, just through clever design and use of materials. And it was cooled in the summer, again, just through a clever design, correct orientation, and placing of elements that you would have had anyway. So in total, the house worked out cheaper than it would have been using the traditional way of construction, but it was much more comfortable than a traditional or normal house in that climatic zone. So we won an award from the Regional Institute of Architecture. I think it was in 2008. And then the next year, because it's usually a year later, the national awards for the same house. And then, that started principle of designing in that way for which we weren't chasing awards really, but designing in an alternative way and thinking of new ways to design and use traditional elements in a new way or an alternative way, in a better way, was recognized by certain bodies as being progressive, and therefore we won some awards for those.
And what was the customers' feedback after living in that house for a year or two?
I think they really enjoyed the house, especially obviously saving on electricity bills and so on, and not having the need for air conditioning or anything like that, or even a fireplace or heating source. So it was quite neutral. There were more issues about, say, the fully glazed southern side where the neighbors complained that they might be able to look into their back garden. So we devised screens that were not solar shading screens, but actually like privacy screens. So the balustrade became a screen that you could look up, but you can't look down. It created privacy for the occupants, obviously, of this house, but it also created privacy then or the perceived privacy, really, I would say, for the neighbors to the south. Otherwise, it was a low maintenance or nearly no maintenance house, a low energy usage, and a lock up and go, which suited their lifestyle.
Now, you went on to design your own house and build it, didn't you?
Many years later, really, it all came about where I wanted to start doing work in an upmarket new housing estate, which was part of a dairy farm next to the oldest golf course in the area. And they subdivided part of their land to create a housing estate with the dairy cows still grazing in like crop circle areas between sections of the houses. So it looked very idyllic. It was like living on a farm in the city. So that was the one reason. The second reason is I wanted to have that kind of profile client. So a way to get that client was to buy a section in the area, design and build a house as an example, and then hopefully get more clients from it. And then the third reason was that I wanted to show that one could, a type of the grid lifestyle or say a more lower energy usage house in an upmarket way, in a luxurious way. It doesn't have to be a mud or adobe or straw bale or earthship kind of structure to be sustainable. It could be something more traditional, say, looking in a sense, and maybe traditional building methods in a sense. Again, it's just how you apply those materials. So that's how I ended up buying the section, designing the house. And then I think a fourth reason really was to experiment. So all the ideas an architect has. And you can't just apply it to a client and then it doesn't work. You have to make sure that it's going to work. But you can do it on your own house and fix the failures, if any. So the idea was to experiment with different construction methods in the same building without making it look like a fruit salad. And then the ones that work, you could reuse, obviously, with future projects. And the ones that don't work, you can change or find out what the mistakes are or why it doesn't work, and then rectify those and redo it in the future. So because of the farm style analogy, or I thought a farmstead would be a good design principle for this house. And then it also justifies using different building methods for each building, forming this farmstead. So the main house was a long barn of 25 meters by 5 meters by 5 meters high. So the second story was sort of half in the roof, and the ground floor was on ground floor, obviously, with 2.7 ceilings. And it was a hot rolled steel portal frame structure. And then I used non-load bearing light gauge steel frame wall panels and roof panels, really. And then a radical, in those days, way of insulation, and that was outsolation, but basically insulation board. And those days, the best one could get was XPS board, which offered a better insulation value per thickness and density than EPS, and then battens and cladding. So in a sense, blocking the entire light gauge steel frame with insulation. So it would be useless to insulate just inside the steel frame, because all the steel frame studs and noggings would be thermal breaks. And even to put a 10 millimeter strip as a break on top of the outside of the studs and noggings is also nearly useless, because it offers a really minimal thermal break. So it made sense to use insulation boards right round. And then we also used it under the slab and in the roof. So it was basically like a cooler box with a lid on it. I always try to explain to people, would you have your chili bin with beers in it without the lid on? The ice is just going to melt away. So you need to insulate the roof. Would you have your beers on the ground and put your chili bin upside down over the beers? No, the ice is going to melt away. So you have to insulate the slab, under the slab. Or would you just put your beers down, on the ground with the ice and then put the lid on it, but not in the box? No, you won't do it. So you need to insulate the wall. So basically you have to insulate the entire envelope of the building, and everything needs to be continuous. Otherwise you have thermal breaks of some sort. So the traditional way of insulating between the studs and nogs, you have all the timber as a thermal break. So between, I think, 20% and 40% roughly timber in most houses. And then also some of it's not even insulated, because the way it's constructed is you have the timber frame and then you put the membrane or the RAB around the building. And then usually the corners are already covered, and then you do the insulation and you can't get to the corners. And those are the critical points anyway. And then the areas around openings and where the roof meet the wall is where you've got more timber. And those are the other critical points anyway, where the hot air is going to rise to and then escape. So it doesn't make sense to really insulate between the frames. You have to outsulate. So that was the main structure. And then we tried with the front building, which became a double garage, wood workshop, and our office on top of it in the roof. I like double uses for everything. So that I used a timber frame building with insulated SIPs that we developed and tested through the university's structural department. And we failed the first test actually, and then fixed those issues and then passed the new test. So we actually developed SIPs that would work. And it was basically magnesium oxide board on both sides of XPS, initially glued with epoxy glue, which then if you do the impact test would shatter, and then the magnesium board would fall off the insulation board, which obviously is not ideal. So we developed another glue that could flex, that actually worked, and then passed all the tests. And ended was actually so strong that we didn't need the timber frame at all. We could have just used the SIPs, but we had both. So we had sort of belts and braces. And then the back structure was another double garage with an apartment above, which we could rent out. And the double garage also served as a steel workshop. And that was entirely light gauge steel frame. So to try that out and how that would work. So fully load-bearing light gauge steel frame, double story. And then the entrance was a brick silo with concrete between two brick skins and insulation. So we had a gap between two brick skins with concrete and insulation. The concrete was mostly there to accommodate cantilevered concrete stairs that need to be tied into the wall, and the brick wasn't strong enough just to handle those loads. So we had to use concrete and reinforcing inside the wall to tie those stair treads to. And then maybe just another interesting story is if we went for the traditional way of raft foundations, which we had to use for the sinkhole area, where sinkholes from 3 to 5 meters can, basically collapsing ground underneath the house. So you had to design for that. So if that would happen, your house or building needed to span over or cantilever over such a hole. And you're using a raft foundation, you're basically doing that because you have ground beams in a square pattern. So that could span and cantilever across such a hole, potential hole. But it was very expensive compared to traditional, say, strip foundations on compacted soil. So what we did is I thought of when I was growing up again, my dad, they were building a line, like a railway line, and crossing some valleys. And the valleys had obviously bridges, and these bridges were these pylons with a reinforced concrete tube basically spanning these pylons. And then the train would be riding on top of the tube and the services would run in the tube. My dad took me with one Saturday to go show me where they would build these two tubes from each side and then they'll meet somewhere in the middle. And we walked inside of one of these tubes and we ended at the end, and it's like very, very high to me. And it always stayed with me. And I thought, oh, well, if this reinforced concrete tube can span across pylons, then it can easily span across a hole in the ground. And then I thought, okay, well, what if I create a concrete tube for the main barn? And then I can utilize the space inside the concrete tube, like the services in a railway line or a railway bridge. And the house just sits on top. And it can obviously span over or across a potential sinkhole. So I dug a hole. It would work if there were no big rocks, because then it starts becoming expensive to get rid of these rocks. So we started digging and we only found like one boulder in this footprint of 5 by 25 meters, which was great. And we got rid of that. And then obviously compacted soil, put on a membrane, put the insulation down, cast a reinforced concrete slab with starter bars for the walls, and then used double skin brick with a cavity, which was then filled with Rio and concrete, and then tied that again to a reinforced concrete slab on top, and then put insulation on the outside, touching the insulation under the slab, and then taking that through right up the light gauge steel frame structure and across the roof. So basically the entire envelope under the basement cellar, which was 1.2 meters above ground on the one side and 500 or 400 above the ground on the other side because of the fall of the land. So that also created an opportunity to provide windows in the upper part of the one side, so to create natural light in the basement. And then that was an ideal place to put water tanks, battery packs, filters. There was a natural gas connection, so we had a gas burner as well. So to put all of those things in fact, we had so much space then suddenly that we had to try and find uses for that extra space underground. And it costs less than a raw foundation. So again, it's just thinking outside, not to square the box, like outside a 3D box, and just utilize what's available to you and resolve the challenges and the issues that one might come across on a certain site.
You were talking earlier about, as an architect, you try things out on your own home. Were there any things that you felt didn't work as well as you'd hoped and you do them differently now?
I think the one was the SIPs, where basically over-designed it by having a timber portal frame and then cladding it in SIPs, where the SIPs were actually strong enough to carry its own weight plus the load needed for a residential building at the very least, even with an office with lots of architectural books that are heavy. It was still over-designed. So if I wanted this, I could have saved money and time by not having the timber portal frame, although it looked really good, having the portal frame in the office and everything painted white. And then the SIPs, basically it looks like plasterboard because you've got a magnesium oxide board facing it's the inside, but on the outside of the portal frame, all painted white. So it provided good natural light, lots of reflection of light. We didn't have large windows, but the correct placement of the windows, especially like triangles near the gable, because it's, roof SIPs on top of the trusses. So you have the open space of the trusses and a feeling of much more space. And then obviously the hot air rises up into that, say, rich space as well. And then by having two operable windows in the upper ridge triangles on both ends of the shed or barn, the hot air rises, and with a slight breeze, you pull the hot air out of the building. And then in winter, basically it's on a little actuator and a thermostat. So if it reaches a certain temperature, the two windows open automatically, and then you have the cross breeze and it extracts the hot air, and you've got more windows lower down that pulls in cool air. And then in wintertime, it closes, and then the heat builds up from the ridge down to the bottom. And then at human scale or lower down, you start feeling the heat, and it's basically a insulated box that's filled with hot air. As long as you don't open a window, come in and go out too many times, you don't need anything else to stay warm. Even like with computers and a human body heat, it's enough to heat such a space. Yeah, so that's one lesson I think I learned. The other thing is I tried the idea of going totally home automation C-bus. And I think two things, it was unnecessary, really. I think normal light switches can work, although you could set a lot of things, especially around energy use, and you can control and monitor energy use better with such a system. And the other issue I would say is that at some stage it will become dated, even if it's 40 years later or whatever, and then you can't find components anymore. And so then it becomes redundant. And if you want to design something that's going to be long lasting, and I'm not talking 50 years, I'm talking, lasting, then you also have to think about things that might become redundant at some stage and that you won't be able to find parts, or there might be something much better, much newer, that's much more efficient or easier to use, like say light switches that uses radio waves or Wi-Fi or whatever. So you don't even need cabling anymore, wiring anymore. So that was one thing to consider. The ways of building, I would say the portal frame with the light gate steel frame, again, it was a little bit belts and braces, because the light gate steel frame building on its own is totally self-supporting and load-bearing, so you don't really need it. But again, it created a beautiful effect. Plus, it acted as support for precast concrete slabs of 1.2 by 5 meters, which would span from portal frame to portal frame. And like that steel frame, you would not have had a concrete floor and all the advantages around a concrete floor. You can obviously resolve the disadvantages of having a mid-floor and like that steel frame by doing certain things acoustically and, sound and fire wise. But the concrete offers a lot of that automatically. the hollow concrete precast slab floors. And it's more a commercial application, which I utilized in a residential application to show that it's actually more cost effective than in situ slab, or even a timber slab with all the acoustic and fire treatments that one would need to add to a timber joist or rafter floor, or even like a steel frame trellis work floor, to have the same qualities and abilities than the concrete floor in the first place.
Now, Freidrich, probably not many people would be aware that you can go snow skiing in South Africa, but you actually got involved in a project with a ski lodge, didn't you?
Actually, the backstory is that I started skiing in Israel. Long story how I ended up in Israel, but basically there's a mountain towards the north called Mount Hermon with an H, but pronounced in Hebrew with a Ch. And there I had the opportunity to have one day of trying out skiing, and I just fell in love with it and ended up going to Europe every year about to go ski. And then there was a guy that also fell in love with skiing in Austria, but he thought he was more clever than I was. So he thought, why don't we ski in South Africa? And there was actually already a sort of a ski resort called Tiffendale in South Africa to the southwestern border of Lesotho, but on the South African side. But he looked at places where there might be snow in Lesotho, which is like the alpine region of South Africa, but Lesotho is a landlocked country inside South Africa. Because of these mountains, there's a lot of rain because it's close to the coast, so the moist air hit the mountains, and then it rains and snows. And then South Africa built dams in Lesotho and for water for the highest population areas, which was Gauteng, which is Johannesburg, Pretoria area, and by river basically transported the water from Lesotho to Gauteng to supply Gauteng through the Vaal Dam with water. But apart from the water, there was also the snow, and there were areas where, like, say, little amphitheaters, one could say, or large amphitheaters, where facing south with no northern sun. So if there were any snowfall, the snow would remain there for a very long time. So he found this one specific spot where there's an army camp near there, and because of that, they had good weather monitoring system and records. And for the previous 50 years, and that was like 2005 or 4, the previous 50 years they had records, and it snowed every year for the past 50 years, at least 0.5 meter per year. And then he went to negotiate with the king, because it's still a kingdom and all the land belongs to the king. And you can only sort of get permission to rights to live or use the land from the king. So he went to negotiate with the king, and the king gave him a long-term lease. And then they had the idea to obviously start a ski resort and many other things like a golf course and so on. The golf course never happened because, I mean, most of the year it's covered in snow, it's too cold, below freezing, and so it's not ideal, and it costs a lot of water, which they have, but high altitudes it's difficult to grow, say, lawn at 3,300 meters above sea level. So the ski resort idea started, and then we got involved by looking for opportunities, obviously, to do more projects, and this sounded ideal because I like skiing, and they need an architect, obviously, and there's opportunity for investing, and there's something new coming from this, or could be coming from this. So a few guys put their money together, including me, and we bought 3 pieces of land, or basically one large section that could be subdivided into 3. But there wasn't a lot. There was the ski lift, a few dams to make snow, like a fiber cement structure that was the office of the contractor that built the footings for the ski lift and the dams, and that's it. So to try and build there, you had to take everything up there, laborers and food and materials and everything, up 2 passes, which takes about 2 hours from the nearest town, and then take them down again every day. So 4 hours lost, and if you forget nails or screw, you're screwed. And then the weather conditions up to 200 kilometer an hour winds sometimes. In winter, it could be minus 25 up to 10 during the day. And during the summer, it could be like minus 10 up to 20. So massive temperature changes between night and day. And then the dam's water was used for snowmaking, so not depending on nature itself on its own. We had to find a way to quickly provide some accommodation, so people not only building more buildings, but also people that come to ski have the same problem. You get 400 people or something arrive on a day and then ski, and then they all have to leave again at the end of the day, and all the staff, everybody, because there's nowhere to live. I saw buildings on the way down there, farm buildings or farm structures really, that were steel portal frames with sheet metal roof open to the sides that farmers used to store their hay for the wintertime, for feed for their cattle. And I thought, okay, this is something that's already made. It's cheap, it's mass produced, quick to erect. So this could be a good solution for this place, which we called Afri-Ski in the end. And now it's become the Afri-Ski Mountain Adventure Resort, I think it's called now. So we put up this portal frame, which is like cast concrete pads, put up the portal frame, used a light gauge steel frame around the entire frame, insulated, clad it. And that was the first building really, and could accommodate a few people and was fully booked all the time for everything, that's needed at the resort. There was another kind of a start of a building, but it wasn't, it just started and then stopped. So they finished that and created a restaurant and basically ski renting facilities and stocking all the skis and so on that needs to be rented out. And so that was good and needed, obviously, as well. And then we thought, okay, what's the next way to get quick accommodation on site? And we thought of shipping containers, obviously, and learning why shipping containers are not ideal for anything other probably than what it's made for, which is transport stuff on ships. So the lessons learned really from it was that if you cut holes through the walls, and the walls are thick and strong quarter-inch steel, which obviously gives it its structure, but then you cut the structure away and it's got no other structure. The thin, say, frame is too thin to carry anything, and the walls really provides the racking and strength for the units. So you have to reinforce the holes when you make a hole in it. And then the other negative would be is that it's 2.4 on the outside wide, but that means it's 2.2 on the inside. And then depending on whether you're insulating inside or outside, like say you insulate on the inside, you're taking more space away from the inside. And then it becomes very impractical apart from maybe for toilets and showers, ablutions. I think the third thing is really that it's a steel box, and a steel box is really hot in summer and really cold in winter. So you obviously have to insulate it on the outside. But it worked for what we intended, and basically we used 2 or 4 40-foot containers, put it in a square or a rectangle with doorways, one could say, in diagonally opposite corners, which created like a fire exit the one way or the other at least, or 2 entrances, exits. Basically, we installed a gum pole, poles and beams in the courtyard, and then covered the entire thing with sheet metal sheets, continuous sheet metal sheets. Then we used, canvas from an advertisement board because it is hardy. It was cheap because it's like an advertisement that's redundant, and it was continuous with, seams or joints. So no chance for it to leak. So we covered the entire roof with that. And then we put all the swirl and the sods that used to be on the side back on the roof. Well, insulation and then that on top of the roof. So basically the swirl and the sods protected the insulation against the sun and blowing away. So anchoring it, and adds thermal insulation to it as well, and then provides a green fifth elevation to the building. But it's very rudimentary, container structure. So on the outside, we insulated the entire thing with insulation board. Initially, to protect the insulation board, we mixed glue and soil, like just normal wood glue and soil, and painted the insulation board with that. But the intention was to rock clad it, but that takes a lot of time. So for the boards not to deteriorate in the sun, the high UV at that altitude as well, we covered it with a glue and soil option, which worked really well because it blended in well with the area, obviously, with the same color soil, protected the insulation board, and then it gave time for the rock layers, which were like basically local sheep herders, to clad the entire building, which is the traditional way they're building their little round houses and shelters up in the mountains anyway. So using local material, local skill, and only basically bringing cement in. We thought of dry stacking it, but at that height and so on, we were concerned that it might fall over and hurt somebody, especially again with the weather conditions. So we thought, okay, we'll have to use some kind of adherence, and so we just used the cement mix to do the walls. And then that provided about 24 beds. So we welded angle iron beds, bunk beds, as many as we could, into 3 of the containers in different configurations of 2-bed to 8-bed bedrooms. And then a 4th container was ablutions and a kitchen. And in the courtyard had a pool table and a ping pong table and vending machines and picnic tables. So everybody could gather there and party and, So it became a really popular backpackers during the winter season for basically everybody because it was nearly the only accommodation available. And then during the summer season, a good contractors accommodation to build more buildings for the next season. So we learned a lot from that and decided, that was too difficult and there must be better ways to do it. So we started looking for pre-manufactured building systems in South Africa, and there weren't really anything apart from site offices, which are basically SIPs screwed together, that doesn't look good, have exposed surfaces, looks cheap, for a ski resort. It doesn't make sense. You want something cozy and natural looking and a little bit more upmarket, definitely more better than shipping containers. And as well as the weather conditions, high wind situations and so on. It wouldn't have lasted very long. So we ended up visiting a few places all over the world and deciding on tongue and groove, like triple tongue and groove, solid timber wall chalets made in Estonia. And I used their system to design a 3-bedroom, 2-bathroom and a 4-bedroom, 3-bathroom ski chalet, like upmarket. And they came with German-made double-glazed windows and doors and skylights. And we had to put them on, say, a traditional timber floor. So we had to insulate the floor first. And then it's a long story, but basically we launched this whole idea of 112 sites with these chalets. We sold all 112 in one night, 100 with loans and 12 cash.
Wow.
Then through a long story, the banks cancelled all the loans. Just a thing between Lesotho and South Africa. And basically because it is Lesotho and it's a very small market, they didn't have the budget to actually provide that amount of money in one shot in this little country where nearly nobody has, building loans to start off with. So we went ahead and bought 12 chalets for the 12 cash buyers. An Estonian team came with the first one, and we upskilled local sheep herders again to build in that way with the Estonians. So it was quite interesting, the Estonian-speaking Estonians with the Sotho-speaking Basutus and us trying to speak English in between, train these guys that have no schooling even. So they can't read, they can't calculate or anything, measure. So it was quite an interesting, but it is a kit of parts. So if you know how it's put together, you don't need all those skills really. And it's a low skill job really. So the Estonians taught the locals with the first one, and then the locals built the other 11 on their own with just us managing them. So again, being very hands-on, this whole thing. And then that worked really well. And when we wanted to continue with that, the exchange rate between the euro and rand doubled. So it was 7.50, I think, for a euro, and it changed to about 14 rand for a euro suddenly. And it just made it not viable anymore to import those units. So we had to think of an alternative. And that's where we experimented with a modular building method, because we thought it's just too difficult to build on site in Lesotho, like 4 hours away from the city, up mountain passes in those weather conditions, even if we had accommodation now for workers and food to feed them and so on. So we decided, let's design a modular system and build it in the city and truck it to site and place it on pre-prepared foundations. And that's basically what we did. So we did a proof of concept again using our SIPs and used that as a show unit, but then decided against the SIPs and the sandwich floor system that we designed for many reasons. Ended up with a hot rolled steel frame, basically with light gauge steel frame infill walls for many reasons again, and then outsulation around the entire box. And then we went through various ways of picking it up, like from underneath with slings, or through the floor with forklifts or slings, or from the top, and going through all those phases and the negatives of all the others, we ended up picking it up from the top and designed certain systems to be able to pick it up. And the other biggest issue, believe it or not, was moving it around in the factory. So we designed and made many types of wheels that mostly folded under the weight eventually. But we ended up with a good end solution in the end. But we went through probably 6 iterations of different wheels just to move the things around. That is if you don't have an overhead crane, you've got a low budget to do these kind of things. It's not a factory really either, because all the parts are really made by specialists and then delivered to a central place. And so it's really an assembly plant. And then all the parts are just assembled into volumetric modules, doing as much as we can there instead of on site because of all the problems on site or the issues on site. Also including health and safety. You don't want scaffolding, you don't want the weather conditions, mud, theft, all of those things you don't have in a factory. You're working in covered conditions on a flat concrete floor, stable floor, low platforms to stand on, no scaffolding. So just better conditions all in all. So we did actually a very luxurious ski chalet for one client using 3 modules in 2 phases. So it could be expanded to another floor with another 5 modules on top of the 3 modules, and reusing the roof of the first module on top of the 5 modules for the second phase. We furnished it and everything. So we designed and built in the furniture and everything in the city. And then all we had to do on site was there was a rock plate really on this site. So we just epoxy bolted footings to this rock plate. Because the modules have their own strength to be picked up and transported and placed again, we didn't need any other framing apart from little poles, and then placed the units on these poles and bolted it to the top plates of these poles, with some obviously cross-bracing between the poles as well, or in that plane. And then we just needed to add the soft finishes, the bedding and cushions and cutlery and crockery, towels and so on. And we had the first luxurious modular ski chalet, pre-manufactured ski chalet on site. The backpacks was still very popular at this stage, so we decided we're going to double the size of the backpackers. So we thought, okay, we're not going to do shipping containers again, we'll use our modules. So we created like a U of modules, a U shape on plan, reused the 4 shipping containers. So we dismantled that entire building, reused the 4 40-foot containers as another bigger U around the smaller U. So the smaller U created a courtyard again with all the picnic tables and stuff. The space between the new modules and the old shipping containers was a corridor with a central, say, ventilation system really. And then we had another 20-foot container, which we divided into 1/3, 2/3, one for domestic hot water and 2/3 for underfloor heating. Between the units, we cast concrete with hydronic underfloor heating system. And then the open side of the 2 U's, we added a massive double glazed glass box with glass walls and glass roof, which is basically a sun trap or sun scoop, like a sun room, one could say. So the sun would shine, heat the air, heat the slab, plus we've put the same way basically the roof back on top of the entire thing. But this time with solar panels, heated the water in the container for those 2 uses, underfloor heating and domestic hot water. And then the PV panels provided basically LED. And then we had gas bottles for cooking and backup heating, water heating. So there's a thermostat. If the water doesn't heat to the temperature required, say 50 degrees, and it flows through the gas burner and it's say at 30 degrees, then the gas burner would bring it from 30 to 40 or 50. So just saving a lot of energy in that way. And at that altitude, you don't use the full bottle capacity either. So you're less efficient. So you have to find different ways to be more efficient as well. So that's how the doubled, or more, it's like 96 bed backpacker came to an existence. And since then, luckily, I think fortunately, a lot of other people started picking up on the trend and designed and brought their own modular systems. I was also involved in designing or creating the construction guidelines and the architectural guidelines. So they all have to operate within those anyway, just for good practice, safety, a language, like a certain language, architectural language for the resort to create order, and not lots of materials blowing away and all over the place during high wind, periods, and make the site look decent or fairly decent most of the year, not like a construction site. So just all of those kind of things. So we were involved in that part as well. It became a very interesting lifelong, really, because it's been 20 years and I'm actually still involved in some way or another, even remotely, living here in New Zealand. 11-hour difference, sometimes problematic for meetings and so on, but it's a good learning curve again, lots of experience gained from it in many ways, construction ways, the altitude, the climate, how to design for it, and then all the other things, how to set up and run a resort, all the challenges that comes with snowmaking and skiing and snowboarding. And at least it afforded me some time, although I was there many times with good snow and I was working too hard to even go ski, or at some stage I switched over to snowboarding. Yeah, so even to snowboard every time I'm there, although I would have loved to if I could.
Wow, quite a project. Now, 10 years ago you moved over to New Zealand. Tell us about that.
I just liked the idea of, like I said previously, variety. At that stage, I thought both myself and my wife needed change and a new experience and adventure in our lives, as well as for our young daughter, like early teen or preteen even at that stage. So just thinking about her future, thinking about new adventures from an architectural side, alternative ways of building, alternative clients, learning from, another source of experience of how things can also be done. Different climatic zones, obviously, South Africa is more a semi-desert area, although the tourism boards pay offline is the whole world in one country, which it really is in many ways. Beautiful country with many different climatic zones, from full-on desert to semi-desert, high altitude, like the high veld, then the low veld, which is subtropical, tropical, the alpine regions in Lesotho and next around Lesotho, because the Dragon Mountains or Drakensberge extends nearly from Cape Town right up to the top, but through Lesotho, and then Mediterranean climate in Cape Town. So we designed buildings in a lot of those regions, and I learned how, you design differently for different climatic zones. and one design doesn't fit all. You have to think about the conditions and how to design specifically for it. For instance, in the alpine conditions or desert conditions, you have a closed, controlled environment, and you keep the heat in and you keep the heat out, depending on the season. In a subtropical climate, and that's usually a dry climate as well, so you have to create humidity or moisture. In a tropical or subtropical, it's humid and it's hot most of the time. So you want good cross ventilation. You can't have evaporative cooling because it's already so humid and moist that it just worsens the whole thing. So the circumstances. So basically there you need a big veranda or a pavilion with no walls, with large overhang. So even if it rains, you can keep everything open and get cross ventilation, and preferably the sea breeze if you have access to the sea breeze, which is usually cooler to cool a building, and you don't have to worry about heating it. There's a few days, maybe a year, and then you wear a jumper. But the rest of the time you just have to worry about keeping it cool without air conditioning. For instance, we did design a house called the koi house because the clients had 60 pet kois and they were living up in the Highveld, but they were thinking about retiring later at the coast because they love the coast and they love playing golf. And they thought, they can build this house, use it as a holiday house, and then later becomes their final house, their retirement house. And so they bought a section on a golf course in a security estate in Belita, which is about an hour north of Durban on the coast, and on a forest next to the golf course down at like the end of a cul-de-sac. A beautiful, actually ideal site. Helped them, discuss what site to buy and which would be ideal. And so we designed this, I would say, contemporary pavilion. So a lot of people were designing and building what I call prestige. Is like a copy of Bali architecture or something that's, in a sense, it makes sense for that area in South Africa because it follows the kind of architecture you need for those climatic conditions, but it has nothing to do with the culture of South Africa. And there's no context apart from that. So I designed something that, there's no context really to follow apart from maybe the locals that used to live there in round huts, which are basically laths with adobe, which they would recover every year with a thatched roof. So that wasn't allowed in the first place within the architectural guidelines in the state, and then also not practical because who's going to recover the house with mud, every year, once a year. So I designed something that I thought appropriate, accommodating the koi being or could be totally off-grid, although they were still connected to local council services, and not needing any air conditioning. The client didn't believe that it wouldn't need any air conditioning, so luckily we designed for it from the start as well. And with that, I mean all the ducting and so on, because if you don't, then people stick it on the walls, all these ducts and things, and that usually looks really ugly. So we designed for the air conditioning. They put it in and they've never switched it on. They just spend a lot of money on air conditioning, and we spend a lot of time in designing ducts and stuff for all of it. That's, for the cooling element and power, obviously.
So, Freidrich, just sort of coming to the end of our interview today, tell us a bit. So, since you've been here, I understand you've got a project that you're working on now in the Australian outback, where you're taking some of those modulate principles and applying them to that climate.
The site that the client bought is near Mount Victoria in the Blue Mountains, and basically a eucalyptus forest area. The challenges or opportunities of that site is that it's a Bell FZ zone, so bushfire attack level FZ, which means 60-minute fire-rated building from the outside in case of a bushfire. And then there's no services apart from a sewage connection point. And then it's about 4 hours away up a pass, again, the same situation that we had in the city, away from Sydney. So again, it made sense, and it's not the solution to every problem or challenge, but it made sense to do a pre-manufactured volumetric unit, because even if it's pre-manufactured panelated, you still have to build scaffolding, accommodate the contractors, or drive up and down every day and pay for that and lose that time and use that energy and fuel and, carbon dioxide, all of those kind of things. So it made sense to build a volumetric unit in the city and then take it up once and place it there. So I designed a fire-rated, a lightgate steel frame structure, insulated with fire-rated rock wool SIPs or panels. And they're not necessarily structural, but they are in a sense because they provide racking as well. And then I like to use everything with a double use at the very least, if not triple or more. But for instance, the external panels are then fire rated or provide the fire rating for the building as well as the thermal insulation. And then inside the walls, we'll further insulate it. So that means we can use thinner external panels, which are obviously cheaper and lighter for transport and crane costs and so on. And the internal framed insulation doubles as acoustic insulation, adds to the thermal insulation. And then the same with the roof, really. It's SIPs again, but then tapered boards on top of that to allow water flow off the building. So you can use those SIPs in a flat position, totally flat position, and then that simplifies the structural design. You don't have some high walls and some low walls, all of them are the same height. But then you create the fall with the tapered boards, which creates extra insulation anyway on top of the SIPs. And then planting the roof with soil and sedum, which has like 7 advantages. Some of it being that it anchors the building, so it creates weight. It protects the waterproofing against the sun and fire. It's a green facade again because you see the unit blends in because of it, because it's lower than the road. It filters the water, provides thermal insulation. Yeah, so many advantages of green roofs again as well. So it doesn't necessarily cost more, but even if it does, with all those advantages, in the long run it costs less because you protect the insulation and you protect the waterproofing. If you don't have to replace that every now and again or maintain that every again with the costs related to it, plus scaffolding and all of it and the safety to get to it in the first place, the initial maybe partly extra cost of a green roof, equalizes or balances those, say, medium-term costs out, and in the long run it's definitely cheaper. Solar panels for electricity generation, placing it on 2 precast concrete, which is you can buy off the shelf for farms again, bases or massive columns, one could say, 3 meter diameter by 2.1 meter high. And the one is then domestic water and the other one is for firefighting water, which you have to have on site as well in that area. And then it's for an artist, so we're going to also use corten fins that are wavy to create a screen around the entire building, which then also make the building blend into the eucalyptus forest better and disappear really in the forest. Yeah, so it's a very exciting project, and to do it properly, I'll probably have to go build it myself again as well, but I'm quite excited to do that and again make sure that everything that I've designed works. And then, yeah, who knows, maybe there's a business plan for that and to roll them out in New Zealand and in Australia, because it's designed for conditions and materials available here, which is, again, different to South Africa. So thinking about local climate conditions, materials available, skills available, and how to best utilize that to create something like this here.
Awesome.
And in Australia.
Now, just as a final point, obviously, since I've met you a number of years ago, we've talked a lot about, obviously at ProClima, we have quite a bit to do with the Passive House Institute and building passive houses. You've obviously had a long career of sustainable design and energy efficiency components to your construction. What are your thoughts about the actual passive house standard and the whole measurability and scientific nature of passive house when applied to construction?
From my experience, I could honestly say that one cannot not afford to build a passive house to passive house standards. The council or the building guidelines, I could say, is a minimum standard, not a target. Most people see it as a target to achieve, and as long as they achieve it, they're good, and their building's going to be fine because council says if you achieve these targets, it's going to be fine. Council sees it, I think, as absolute minimum standard to comply with, but it's much better for you if you do much better. And passive house design principles automatically provides the platform for good design through the 5 pillars, for instance, of, passive house standards. And that's just to insulate properly, which I've explained, I think, through what I've said on a few projects, why that's important and how to do it. Basically thinking about the correct R values and have no thermal bridging. And that's not followed in 99.9% of any structure in New Zealand and Australia, probably Australia worse. And then the holes in the thermal envelopes, obviously the doors and the windows. So minimize the holes and think about where do you need light and sun and views, and use glass only for those spots, which makes it much more valuable than having an entire wall of glass. If you restrict it to, walking past the wall and then there's a window that frames a certain view, it's much more precious than having the entire view exposed all at once, all the time. And then obviously try and get the highest R value from that hole that you're making in an insulated envelope in the first place. So best windows at the moment really available here is R1, where, wall needs to be 2.8. So it's far below already, and it's very difficult to achieve a R1. A 0.5 is more achievable. So you have to cut your losses and accept that you can have holes, but then minimize those holes. And then because you create an airtight envelope, so creating an airtight envelope gives you the opportunity to control the indoor climate, really. If you have control over it, you can decide or control how hot or how cold or how humid or how dry it could be, far more so than just allowing nature to decide for you whether it's going to be hot or cold or humid or whatever. And then the next challenge would then be, because you can control it, you have to control it. So you need a ventilation system, preferably a heat recovery ventilation system, because when you don't want to lose the heat that you've spent energy on to create inside the space, but you still need fresh air, and the fresh air might be cold. So you exchange the hot exhaust air, or some of it, you allow to escape, and you replace it with fresh air, but you also exchange the heat from the hotter exhaust air to the cold fresh air, which means that you need less energy to heat the rest of it again. So with passive house, there's 2 standards, the air exchanges that you require, and then also the air tightness that you require. And that's basically the result or the measure of being a passive house. But in principle, it's just good to follow all those principles. Even if you don't aim to get passive house certification or meet that exact requirements to get the certification, even if you're on the way there, it's much better than, say, the traditional current way of construction. Always, I see new houses going up, timber frame, and then they've got even 300 stud spacings, and that house looks like it's got 50 or 60% timber. They could have just gone CLT really in the first place, cross-laminated timber, solid timber walls, and then outsulate. And then I wonder, are they going to outsulate, or are they going to try and squeeze a little bit of insulation between those studs and feel satisfied that they've insulated it, and council's going to tick it off, and then they spend millions on this house, and then it's not going to be comfortable. And what's the aim of providing a house? It's first, it's shelter, it's home, it's a place to call home, to go back to, basically a store for all your possessions and to keep it there and safe. And then the rest of the time, part of the shelter part of it is you want a comfortable place to live in and spend your time, and you don't want to, feel uncomfortable. You don't want to be hot and humid in summer. You don't want to be wearing layers of clothing inside. And sometimes it's even colder inside than outside. And then you wonder why, especially after you've spent millions, or even if you don't, like spend, your life's savings or income. If you think about, paying 2/3 of interest and 1/3 on the building itself, and then you're paying it off over 30 years or 20 years, you're basically paying most of your income from your entire life for this substandard building that you're uncomfortable in. So why would you do that? If this is the thing you're going to spend the most money on in your entire life, whether you're corporate, a company and it's your offices or whatever, where your personnel needs to be comfortable to be more productive, which means that you'll be more profitable if they're more productive. So why not spend a little bit more up front? And a little bit, I mean, like even if it's 20% more. If the original cost of a building is, say, 100%, but then your long-term operational and maintenance cost is another 60 or 80%, extra over the lifetime of the building. So if you're going to spend 20% more initially, it's a fraction of the lifetime cost. If you're going to retain the building, it makes absolute sense. If you're not going to retain the building, it makes sense in the way that you're at least saving the resources of the earth, which is limited, and you're providing, better stock for the long term instead of bad stock. I always say if you're not part of the solution, you're part of the problem. So if you create a substandard building, you're creating a problem for yourself plus the future generations. If you provide a good building, then you not only providing good building for yourself, but you contribute to the longevity and the future of next generations that's going to live and buy that house and live in it, in the future.
Awesome, Freidrich. I really like your summary there at the end, and thank you so much for your time here today.
Thank you. It was a pleasure speaking with you, Simon, and thank you for the opportunity to give you like a glimpse of a part of my life.
Great. Sharing knowledge is at the heart of our strategy to make buildings better for everyone. Sign up for our podcasts to learn more about creating healthy living conditions by protecting building structures from external and internal moisture damage. Thanks for listening. Looking forward to having you with us next time.